फर्स्ट डे ऑफ टेक्निकल इंटरव्यू प्रिपरेशन सीरीज। आज ट्यूसडे है और आज का हमारा टॉपिक है बेसिक स्टैटिस्टिक्स का क्यूएनए। हम बेसिक स्टैटिस्टिक्स को क्यूएनए क्वेश्चन और आंसर के फॉर्मेट में लर्न करेंगे और इसके वजह से क्या होगा कि जो इम्पोर्टेंट टॉपिक्स है वो आपको इजीली क्वेश्चन आंसर फॉर्मेट में बताने की वजह से आपको इजीली उसको लर्न करना आसान हो जाएगा। ठीक है, सो अभी अब हम स्टार्ट करते हैं। सो अल्टीमेट स्टैटिस्टिक्स क्यूएनए। ठीक है, तो हमारा पहला क्वेश्चन है व्हाट इज डिस्क्रिप्टिव स्टैटिस्टिक्स। इस पीपीटी में मैंने इस तरह से किया है कि क्वेश्चंस दिया है और अगर इस तरह का क्वेश्चन और इस तरह के टॉपिक के ऊपर अगर क्वेश्चन पूछा जाए तो उसमें हमें पॉइंट्स कौन से कवर करने हैं। ठीक है, तो हमारे सामने पूरी की पूरी पीडीएफ या पूरा का पूरा किताब कंप्यूटर ना भी हो, सिर्फ हम पीडीएफ के थ्रू हम रिवाइज कर सकते हैं। ठीक है, तो हम शुरू करते हैं। व्हाट आर डिस्क्रिप्टिव स्टैटिस्टिक्स। तो डिस्क्रिप्टिव स्टैटिस्टिक की डेफिनेशन में हम बोलेंगे कि डिस्क्रिप्टिव स्टैटिस्टिक इज प्रेजेंटिंग, ऑर्गेनाइजिंग एंड समराइजिंग द डेटा. In descriptive statistics, we describe our data in the manner and present it in a meaningful way. ठीक है, so that it can be easily understood, and most of the time it is performed on small data sets, and this analysis helps us a lot to predict some future trends based on current findings. Measures that are used to describe data set are measure of central tendency, measure of variability और डिस्पर्शन एंड मेजर ऑफ फ्रीक्वेंसी डिस्ट्रीब्यूशन। ठीक है, तो हम इन तीनों टॉपिक्स को अभी नेक्स्ट स्लाइड्स में कवर करेंगे। ठीक है, सो नेक्स्ट है व्हाट इज मेजर ऑफ सेंट्रल टेंडेंसी। Central tendency represents the whole set of data by single value. It gives us location of the central points. There are three main measures of central tendency: mean, mode, and median. Mean is defined as average, which is the sum of observations divided by count. Mode is the value that has highest frequency in the given dataset. The dataset may have no mode if the frequency of all data points is the same. Also, we can have more than one mode if we encounter two or more data points having the same frequency. Median is middle value of the dataset. It splits the data into two halves. If the number of elements in the dataset is odd, then the center element is the median. And if it is even, then the median would be the average of two central elements. So next question is what is the measure of variability or dispersion? उसे और भी कहा जाता है क्वेश्चन में कि स्प्रेड ऑफ द डेटा सेट। ठीक है, आइदर वे स्प्रेड ऑफ द डेटा सेट, मेजर ऑफ वेरिएबिलिटी और डिस्पर्शन, दैट वुड बी द क्वेश्चन। तो आंसर है मेजर ऑफ वेरिएबिलिटी आर ऑल्सो टर्म्ड मेजर ऑफ डिस्पर्शन as it helps to gain insights about the dispersion or the spread of observations at hand. Some of the measures which are used to calculate the measure of dispersion in the observations of the variables are range. The range describes the difference between the largest and the smallest data point in our dataset. The bigger the range, the more spread of the data, and vice versa. Second is variance. It is defined as average squared deviation. Average squared deviation from the mean or the measure of how data points differ from the mean. It is calculated by finding the difference between every data point and the average, which is also known as mean, squaring them, adding all of them, and then dividing by the number of data points present in our data set. Okay, वेरिएंस को हम याद में रखते वक्त ध्यान में रखना चाहिए, क्योंकि हमारा स्टैंडर्ड डेविएशन और वेरिएंस दोनों रिलेटेड है. सो नेक्स्ट इज स्टैंडर्ड डेविएशन. It is defined as the square root of variance. Okay, how it is related to variance? Standard deviation is the square root of variance. It is calculated by finding the mean, then subtracting each number from the mean, which is also known as average, and squaring the result, adding all the values and then dividing by the number of terms followed by the square root. Fourth is interquartile range. Interquartile range is defined as the difference between 25th and 75th percentile or the third quartile. It describes the middle 50% observations and it is represented by box plots. If we have to see the interquartile range of a particular column in a data set, we visualize it by box plot. Okay. So next question is, what is the measure of frequency distribution? A frequency distribution is the method of organizing data to show the frequency of each possible outcome in the dataset. It helps understanding the distribution and pattern of data. The measures are count, the number of occurrence of particular value in the dataset. It is visualized with histograms, bar graphs representing the frequency distribution of the dataset. So next is frequency. The number of times a specific value appears in the distribution is known as frequency. Third is relative frequency. Relative frequency is extension of frequency where each frequency is represented relative to all present frequencies of the different quantities. For example, when we perform a pie chart or when we visualize a pie chart, in the pie chart, the circular chart is divided into sectors representing relative frequencies. So, relative frequencies are visualized with pie chart. Or the formula we can see is relative frequency is equals to frequency of a given number divided by sum of the frequencies of all quantities. Okay. Next is cumulative frequency. Cumulative frequency is of a class is a frequency calculated by adding the frequencies of all the classes preceding the given class. For example, interval is 0 to 10 and in the interval of 0 to 10, the frequency is 2 and his cumulative frequency, because it is the first value, it is 2. If the interval is next interval is 10 to 20, frequency of 10 to 20 interval is 4. Now cumulative frequency of this set is 2, that is previous frequency, plus current set's frequency, that is 4. That means cumulative frequency of interval 10 to 20 set is 2 plus 4 is equals to 6. Next question is, explain univariate versus bivariate versus multivariate analysis. The main difference between univariate, bivariate and multivariate analysis is the number of variables being analyzed. Okay. Univariate analysis only summarizes a single variable at a time. Bivariate summarizes two variables and multivariate summarizes more than two variables. In univariate, it does not deal with cause and relationship. Bivariate, it does deal with cause and relationship and analysis is done. But multivariate में it does not deal with cause and relationship and its analysis is done. So only bivariate analysis is deal with cause and relationships to get analysis done. It does not, the univariate analysis does not contain any dependent variable because it is only one variable. There is no dependent and independent issue. In the bivariate, it does contain only one dependent and other one is independent variable. And in multivariate, similar to bivariate, but it contains more than two variables. Okay. The main purpose of univariate is to describe a particular variable. Purpose of bivariate analysis is to explain, not describe, explain the relationship. And multivariate analysis main purpose is to study the relationship among them. Okay. So in univariate, the example of height. Okay. Bivariate is the relationship between temperature and ice cells in summer vacation. And multivariate example is, suppose an advertiser wants to compare the popularity of 4 advertisements on a website. Okay, so this is the example of multivariate analysis. Okay, then there is the click rates are measured. Both men and women relationship between variables can be examined. So this is like more real world case when we use multivariate analysis. Univariate dataset is visualized by histograms, box plots. Bivariate data is quantitative measure called correlation coefficient. If you know, we perform a correlation analysis and there we get the correlation coefficients of each column and their relations. And this correlation coefficient range from -1 to 1. The more towards -1 is not related to each other and more towards 1 is they are more related to each other. In multivariate data, goals of analysis are interested in predicting one variable based on others, identifying underlying factors that explain patterns, and comparing group means across multiple variables, interpretation of complex relationship within the data. It helps uncover patterns that may not be apparent when the examining variables individually. Next is difference between descriptive and inferential statistic. This is most common question and people usually are more confused about these two names of statistics. Okay. So descriptive statistics is the information about raw data that describes the data in some manner. But inferential statistics, it makes inferences about the population using data drawn from population. That is, it makes on sample data. Descriptive statistics helps in organizing, analyzing, and to present data in a meaningful manner. Inferential statistics allows us to compare data and make hypotheses and predictions. Descriptive statistics is used to describe a situation, and inferential statistics is used to explain the chance of occurrences of an event. Descriptive statistics explains already known data and is limited to the sample or population having a small size. Inferential statistics attempts to reach the conclusion about the population. Descriptive statistics can be achieved with the help of charts, graphs, and tables. Inferential statistics can be achieved by probability. That means descriptive statistics is more we can done with the help of visualization, charts, graphs, and tables. And inferential statistics, we apply probability. to uncover relationships. Next is, what is skewness? Skewness is the measure of asymmetry of the probability distribution of a real valued random variable about its mean. It indicates whether the data is concentrated more on one side of the mean compared to the other side. So understanding the skewness of the data is crucial for several reasons. Modeling assumptions. Linear models often assume that independent and target variables have similar distributions. Skewness information helps in assessing the degree of deviation from the assumption, allowing for appropriate adjustments or transformations to be made to improve model performance. Second is feature engineering. Skewed data can significantly impact the performance of machine learning models. Knowing the skewness helps identifying which feature may lead transformation. For example, log transformation to make the data more suitable for modeling. Third, predicting accuracy. Skewness provides insights into distribution of data values, which can influence how well a model generalizes to new unseen data. By understanding the skewness, one can anticipate how the model might perform on different segments of the data and make adjustments accordingly. Fourth, outlier detection. Skewed distribution often indicate the presence of outliers, which can have significant impact on model estimation and inferences. Knowing the direction of skewness helps in identifying where the outliers are more likely to occur, guiding the outlier detection and treatment process. Fifth, interpretation of results. Skewness information aids in the interpretation of model results. For instance, in your example of predicting MPG based on car horsepower, knowing that the data is positively skewed suggests that the model may perform better for cars with lower horsepower, which informs decision making and further analysis. Next question is, what is coefficient of skewness? Coefficient of skewness is a numerical value that quantifies the degree of skewness in the probability distribution. Coefficient of skewness is a statistical measure that indicates asymmetry of data around its mean, revealing whether the data is skewed to the left, right, or it is symmetrical. Coefficient of skewness can take values ranging from negative infinity to positive infinity. Skewness can be classified into two main types: positive skewness, negative skewness. So positive skewness, that is right skew. In the positively skewed distribution, the mean is greater than the median, which is greater than the mode. This means that the distribution has no longer tail towards right side, with the few extreme values pulling the mean towards right. Negative skewness or left skew. In a negative skewed distribution, the mean is less than the median, which is less than the mode. This means that the distribution has no longer tail towards left side, with the few extreme values pulling the mean towards left. Interpretation of coefficients of skewness. Coefficients of skewness, positive skewness, description is coefficient is positive. Interpretation is data distribution is skewed to the right, indicating a longer tail on the right side. Negative skewness, the coefficient is negative. The data distribution is skewed to the left, indicating a longer tail to the left side. 0, coefficient of skewness is 0. The description is the coefficient of skewness is 0. That means the data is symmetric. Coefficient of skewness, the Pearson first coefficient formula there is a Pearson second coefficient formula. The Pearson's second coefficient formula of skewness, that is 3 into mean minus median divided by standard deviation. That is, it is less influenced by outliers or extreme values in the distribution compared to the Pearson's first coefficient of skewness. So, Pearson's second coefficient of skewness formula is 3 into mean minus median divided by standard deviation. Next question is, what is kurtosis? It is also a characteristics of frequency distribution. It gives an idea about the shape of frequency distribution. Basically, measure of kurtosis is the extent to which frequency distribution is picked in the comparison with normal curve. It is degree of pickedness or tailedness of a distribution. Kurtosis helps access data's deviation from normal distribution and its tendency towards extreme values. Types of kurtosis are leptokurtic. Leptokurtic is a curve having high peak than the normal distribution. In this curve, this is too much concentration of items near central value. Mesokurtic. Mesokurtic is a curve having normal peak than the normal curve. In this curve, there is an equal distribution of items around the central value. Platykurtic. Platykurtic is a curve having low peak than the normal curve. It's called. In this curve, there is less concentration of items around the central value. The difference between skewness and kurtosis. Skewness indicates the shape and size of the variation on the either side of the central value. Skewness indicates shape and size of variation, and kurtosis indicates frequency of distribution at the central value. Skewness measures differences about magnitude and direction of asymmetry of the distribution. Kurtosis indicates the concentration of items at the central part of the distribution. It indicates how far the distribution differs from the normal distribution. Skewness indicates how far the distribution differs from the normal distribution. And kurtosis studies the divergence of given distribution from the normal distribution. Skewness measures the studies the extent to which deviation clusters are above or below the average. Skewness studies the extent to which deviation clusters are above or below the average. Kurtosis indicates the concentration of items. Skewness. In an asymmetrical distribution, deviation below or above average is not equal. In kurtosis, there is no such distribution, that is asymmetrical distribution takes place. Difference between dispersion and skewness. Focus. Dispersion focuses on variability or spread of data points around the central tendency, that is mean, median. Skewness focuses on the shape of the distribution and the direction of skewness, left or right. Dispersion. Common measures of dispersion include variance, standard deviation, range, and interquartile range. Common measures of skewness include Pearson's first coefficient skewness, moment skewness, and graphical methods like QQ plots. Dispersion measures are not directly related to the mean, although they can affect the mean's interpretation when it's used as the measure of central tendency. Skewness provides information about relationship between the mean and the median. Positive skewness implies that the mean is greater than the median, and negative skewness implies the opposite. High dispersion indicates that the data points are scattered or dispersed widely from the center, suggesting a wide range of values. Positive skewness indicates that right skewed distribution with a longer tail, while negative skewness indicates a left skewed distribution with a longer left tail. Zero skewness suggests a symmetry. Zero skewness suggests a symmetric distribution. Applications are dispersion measures are useful for understanding the variability of data and assessing how tightly or loosely data points are clustered around a central value. Skewness is useful for understanding the shape of the distribution and identifying whether it is skewed to the left or right. It helps assess the asymmetry of the data. Examples of distribution are spread of the test score in a classroom, variability of stock prices over time, or the ranges of ages in the population. Examples of skewness are income distribution, often right skewed, response timing of a website, potentially right skewed with outliers, and exam score distribution, which can be either left skewed or right skewed. What is law of large numbers in statistics? According to the law of large numbers in the statistics, an increase in the number of trials performed will cause a positive proportional increase in the average of the results, becoming the expected value. For example, the probability of flipping a fair coin and landing heads is closer to 0.5 when a flipped 100 and 1000 times compared to when flipped 50 times. This forms the basics of popular hypothesis testing framework. Key decisions in any internet-based company, that is e-commerce, food delivery, OTT platforms, are usually backed by A/B testing, which involves hypothesis testing and that is related to law of large numbers in statistics. We will cover A/B testing in next video and see details. What is the central limit theorem? Central limit theorem states that given a sufficiently large sample size of population with a finite level of variance, sampling distribution of a mean will normally distributed regardless of its population is normally distributed. What general conditions must be satisfied? Central limit theorem states that sampling distribution of a mean will always follow a normal distribution under the following conditions. First is the sample size is sufficiently large, that means more than or equal to 30. Samples are independent and identically distributed random variables. Third is the population's distribution has finite variance, that is a limited variance. Next very important question is assumption of central limit theorem. Though it is covered here, assumption of central limit theorem, it can be asked as a separate question. What are the assumptions of central limit theorem? The central limit theorem is valid for following conditions. First, the drawing of sample from the population should be random. The drawing of the sample should be independent of each other. Third, the sample size should not exceed 10% of the total population when sampling is done without replacement. Fourth, sample size should be adequately large. And fifth, central limit theorem only holds for population with finite variance. Probability. What are the basic probability rules? Probability. What is probability? The measure of likelihood of an event occurring. It is represented as number between 0 and 1, where 0 indicates impossibility, the event will never occur, and 1 indicates certainty that event will occur. Probability allows us quantify uncertainty and assess the relative chances of different outcomes. Basic probability rules are: first is addition rule. The probability of union of two events, if A and B are two events, then the probability of happening either event A or event B occurring when the event A and event B are not mutually exclusive. Multiplication rule. The probability of intersection of two independent events. If A and B are independent events, then the probability of both event A and B occurring. This rule holds true when the occurrence of one event does not affect the probability of event happening, the other event happening. Okay. So complement rule. The probability of the complement of an event. If A is an event, then the probability of complement of A, that is the event not occurring, is given by probability of A. Complement of probability of A is equals to 1 minus probability of A. The mostly asked question is conditional probability, and it can be asked as a separate question. What is conditional probability? The probability of event occurring given that the other event has already occurred. If event A and B, then the conditional probability of A given B is denoted by probability of A bar B. This rule quantifies how the probability of event 1 changes the light of occurrence of another event. The likelihood of an outcome occurring based on previous outcome is similar circumstances. In probability notation, it is denoted as A given B expressed as probability of A bar B, indicating that the probability of A is independent on the occurrence of event B. That means probability of event of happening A is dependent on the occurrence of event happening B. For example, if it rains, then the probability of road accidents increases. So the roads have less friction. Some of the common properties of conditional probability are: property 1. Let's consider an event A in any sample space S of an experiment. So probability of sample bar A is equals to probability of A bar A. It is equals to 1. Okay. So property second is for any two events A and B of sample space and an event X, such as probability of X is not equals to 0. So the probability of A union B bar X is equals to probability of A bar X plus probability of B bar X minus probability of A union B bar X. Property 5. For any 2 or 3 independent events, the intersection of events can be calculated using the formula. For intersection of 2 events of A and B, probability of A intersection B is equals to probability of A into probability of B. For the intersection of 3 events A, B and C, probability of A intersection B intersection C is equals to probability of A, probability of B and probability of C. Next question is Bayes theorem. The fundamental concept in probability theory named after the Revan Normus Bayes. This is the person who invented that. It enables us to calculate the probability of hypothesis being true given observed evidence. The theorem is expressed mathematically as probability of A bar B is equals to probability of B bar A into probability of A divided by probability of B. Prior probability of A, this represents our initial belief in the likelihood of hypothesis A being true before considering any event. Likelihood of probability of B upon A. This indicates the probability of observing the event B given that hypothesis A is true. It quantifies how well evidences support the hypothesis. Evidence probability of B is the term serves as normalization factor and represents the total probability of observing events B across all possible hypotheses. Posterior probability, that is probability of A of happening over B. This is the updated probability hypothesis, A being true after taking into account that observed evidence is B. It's what we are ultimately interested in determining. Bayes' theorem is particularly powerful because it allows us to incorporate new evidences incrementally, refining our beliefs as more data becomes available. Bayes' theorem provides a principal approach for reasoning under uncertainty, making it cornerstone of probabilistic reasoning and decision making in diverse domains. Widely used in fields such as medical diagnosis, spam filtering, and weather forecasting. So, that's it for today. This is the link for our WhatsApp channel, and if you are not subscribed to our joined to our WhatsApp channel, please go there and I will be uploading the PPT and the PDF of detailed Q&A on the WhatsApp channel only. So thank you.